From the last video containing class on mechanical measurements and metrology. As I mentioned in the last video, we have discussed about the line standards. Line standards, they are always about measuring the distance between any two parallel engraved lines. Coming to the next part, that is end standards, it is always measured the distance between two parallel end faces. That's why it is called as end standards. Here, these end standards, they are made to a very high degree of accuracy. That's why they are used for calibrating purposes also. They consist of a standard blocks or a bars used to build up the required length, and that can be used for measurement. Some of the examples for the end standards are slip gauges, gap gauges, end of micrometer anvils, etc. Characteristics of end standards. First is about end standards. They are highly accurate and well suited to measurements of close tolerances. They are time consuming in use and prove only one dimension at a time. Example, a ruler which I can use it for measuring the distance between any two engraved lines, which I can use it for from a defined length. Example, a ruler from 1 centimeter to the 30 centimeter I can use it, whereas it is once it is calibrated, it is done, we can use it for a number of times. But this kind of end standards, we need to calibrate we need to build up every time for a particular only one length. We cannot, example, a gas slip gauge which is built up for measuring the 10.02 mm, I cannot use it for the 10.03 mm also. So it can prove only one particular dimension at a time. However, the accuracy of the end standards, they are very high, that is around 0.0005 mm dimension tolerance can be achieved. They are subjected to wear because each time we need to build up the slip gauge, it need to be rub with respect to each other. That's why they are subjected to wear on their measuring surfaces. They are not subjected to parallax effect, since their use depends on the field, and the group of blocks are ringing together to build up any defined length or specific length. Always, if there is any faulty ringing occurs, then obviously it will cause damage to the blocks, and also it may lead to the wrong measuring of time length. The accuracy of both the line standards and end standards, they are affected by the because both are made up of metals. Then obviously it is a temperature change is going to affect. This is these two, both line standard and end standard, those two are about the material standards. Because a material, a mass is used there, and either a lines are engraved or a rectangular block, and the length is measured between the two parallel faces. That's why those two are material standards. The third one is a wavelength standard. Here it is the major drawback of those two material length standards is the temperature changes may cause the deviation in the length, and over the period of time either wear and other degradation may cause or influence on the measuring aspects. So this third one is to overcome that, a light standard or a wavelength standard is used. Here primary standard, the possibility of using light as a basic unit to define primary standard has been considered, and the wavelength of the selected radiation was measured, and it is considered as a basic unit of length. Since wavelength standard is not a physical one, it need not to be preserved. It can be traveled, it can be taken anywhere, and it is not going to degrade over a time. Further, it is easy reproducible, and the error of reproduction is in the order of 1 part in 100 million, which is a very highly accurate rate. And the definition, here the meter again, we there it is used as a definition as a distance between two engraved lines which is equal to 1000 mm. So here it is defined, the meter is defined as a 1650 wavelengths of a orange radiation in vacuum of a krypton 86 isotope. So that is how the meter is defined with respect to this wavelength standard. And similarly, the AD is defined as a 1509458.35 wavelengths of the orange radiation in the vacuum of a krypton 86 isotope. The AD is defined now as 0.9144 meters. Sorry. The substance krypton 86 is used because it produces highly sharp defined interference lines, and it is almost gives a most uniform light throughout. Advantages of using wavelength standard: length does not change, length is not going to change, and it can be easily reproduced even if it is getting destroyed, because let me say a source of krypton 86 is destroyed, a new source with the krypton 86 isotope that can be used for wavelength standard. The primary unit, it can be accessible to any physical laboratories easily, whereas in case of material standards, primary unit is not accessible. The reproduced physical units or primary units, which we call it as a second units, that is again reproduced for the tertiary method, and those standards we are using it. And further, the wavelength standard can be used for making comparative measurements with much higher accuracy than compared to the material standards. Wavelength standards, it can be reproduced place and at any point of time. Subdivisions of standards: the imperial standard yard and international prototype meter defined previously are master standards, and it can be used for ordinary, it cannot be used for ordinary purposes, whereas for that reason the standards are defined and they are classified into four different grades. So the first one is a primary standard, second one is secondary standard, third one is tertiary standard, and fourth one working standard. So based on the application, these grades are being classified. Coming to the first, what is primary standard? In order to define the standard unit of length, yard or a meter does not change its value and is strictly followed and precisely defined that there should be one and only one material standard and preserved under most careful condition, whether it is a yard or whether it is a meter. A standard bar, which we have defined already, a standard primary bar which is kept in example for a meter bar which is kept in a BIS Paris. Similarly here also, yard is also similarly it is maintained in the laboratory. It is, and this kind of standard we call it as a primary standard, and this standard has not any direct application that need to be reproduced. They are only taken at a very rare intervals, only for comparison with the standards. Coming to the secondary standards, these are all the close copies of the primary standard, where whether it is in terms of a design or a material or a length, it is very near or very close to compared to the primary standard. The primary standard is only one, which is a 90% iridium or 90% platinum and 10% iridium meter bar which is used, and it is very similarly the same another alloy with another alloy bar with the same material and same length, same design is used as a secondary standard. These are all made very exactly similar copy of primary standards, and any error existing in these standards is recorded by comparison with the primary standards where after a very long interval, that is after very rare intervals, the primary standards are taken out and it is compared with the secondary standards. Again, the secondary standards, they are kept at number of places under great supervision, and they are used for comparison with the tertiary standards whenever it is desired. These also acts as a safeguard against the loss or destruction of the primary standard. That's why the secondary standard produced. Next, coming to the tertiary standards. Again, these tertiary standards, they are again a copy of the secondary standards. These again having exist as ultimate controls for the reference at very rare intervals. So, even the secondary standards, they are not taken at regular intervals. They are taken out at very rare intervals, and that's why the tertiary standards are being produced. That they are kept at the national physical laboratories, and they are the first standards to be used for reference in laboratories as well as in the workshops. And they are again a true copy of the second standards. They are kept as a reference for comparison with the now coming to the working standards. These are the working standards. These are the standards which is of low grade materials. We are low cost, and that's why they can be used for in the workshops also. They are again, once the working standards, they are measured, they are produced, they are calibrated with the help of a tertiary standards. They are used for general applications in metrological laboratories. Some standards, they can also be classified as reference standards, which is used in the laboratories for reference purposes, or it is used for calibration purposes in inspection laboratories, and for stand as a standard calibration standard. Inspection standards, they are used by inspectors, and the last one is working standards. They are used by operators on the shop floor. Transferring from the line standard to the end standard. This is very important because line standard to the end, it is always like whether if I am taking a meter bar or a end bar, then obviously those are all the line standards. That is where we are measuring the distance between two engraved lines. Sorry. So we need to transfer this line standard to the end standard, because end standard we can produce it with a high accuracy, which is not to a greater extent in the line standard. That's why the transferring the NPL method, method of deriving the end standard from the line standard is very important. So line standard of length is an inconvenient form of general measurement applications. So in order to determine the position of defining lines in line standard, a special microscope has to be employed, so that if there is any deviation, if there is any inclination of the engraved lines, that also need to be understood, and then it need to be calibrated. And line standard was defined first. That's why the end standard need to be derived from the line standard, and it is of end standard is in a practical application it is very important, and it has got more utility. The end has standard has to be produced to a highest tolerance in relation to standards. In order to transfer the line standard correctly to the ends of a bar, an instrument like called line standard comparator is used. It consists of two microscopes mounted, let me say I am taking a yard example, about a yard apart over a table. At the end standard, about 35.5 inch in length is produced with the end faces flat and mutually parallel with respect to each other. And now the two half-inch blocks are the run to the ends of this end, so that the total length now it become 36.5. Over the two half-inch blocks, the two lines are engraved. One line on each block. So two engraved lines now. So each line on the each half-inch block is maintained such a way that they are parallel with respect to each other when they are rung together. At the center of the end-to-end faces. Now the distance between the two center lines of the engraved block of a half-inch block is measured with respect to the another opposite engraved line of the another half-inch block. When I measure the distance between those two parallel lines, then it will be equal to 36 inches. So here that 36 inches is equal to now 1 yard. The line standard and end standard along with the end blocks are mounted on a table, and the microscope having a highly accurate micrometer screw controlled eyepieces, those are taken. Those two microscopes with the cross wires is made to focus on the lines of the standard, that is on the half-inch block. The table is capable of being transferred so that the either block may be brought under the microscope. The actual length of 35.5 inch end standard is taken as a L now. The distance between the two lines on the line standard is 36 inch. Now the possible errors need to be checked. The possible, like, one is the misplacing of the line at the mid position of the end faces of the half-inch block and the error in the length of the 35.5-inch end standard. The two blocks at the ends may be arranged in four different ways, and one position is shown example here. One is the 36 inch, to get the 36 inch, the 35 inch, the 35.5 inch is kept at the center. That is a first, this is a first combination. And the half inch, let me say it is actually made at a center. If there is any error, then the engraved line with respect to the center, it may be around x1, that is error. Similarly, this is a x2 error. Now if let me call from the center, that is engraved line, to the one end is A and another end is B for a 1/2 inch block. Similarly, for the another 1/2 inch block, from the engraved line to the one end is called C. Similarly, from the engraved line to the another end, let me call it as D. So this combination for the four different combinations, the difference, four different combination is A, B and 35.5-inch block, and C, D, or we can say that A, B, C, D and 35.5-inch block, or we can reverse it, B, A, C, D, B, A 35.5-inch block plus C, D, or we can reverse on the other side as B, A 35.5-inch block and DC. So similarly, four different combinations we can try it. And now the differences, as we can call those differences, we can measure it D1, D2 and D3, D4 respectively. Then the successive positions for the 1/2 inch block, we can give it as L plus BC is equal to 36 plus D1. Now similarly, L plus B plus D is equal to 36 plus D2, because if I am saying, let me call A, B and 35.5-inch block, and then CD, if I am arranging in that way, then the 36 plus D1 will be equal to L plus B plus C. If I am reversing the CD in terms of as DC, then it will become L plus B plus D is equal to 36 plus D2. The another combination is, instead of AB, if I am reversing it as BA, then it will become L plus L plus A plus C is equal to 36 plus D3. Similarly, it is L plus A plus D, it is equal to 36 plus D4. These are the four different combinations. When I take the mean, then 1 plus half of A plus B plus C plus D, which is a 36 inch, a 1/2 inch block, over that it is being engraved, then it is equal to 36 of summation of D by 4. Let me call it as equation 1. So it may, from the equation it may be noted that the possible misplacing of the lines between the engraved lines of the 1/2 inch block being eliminated. So next, 35.5-inch end standard is rung with one of the 1/2 inch block and compared with 36-inch end bar. So the total it should be becoming 36-inch, but if there is any deviation using the Brookes level comparator, if I am comparing, the deviation D1 may be noted in the next figure. Then the 1/2 inch block is rung and again it is compared with the 36-inch end bar, and the deviation D2 is noted. So now the total length L is the actual length of the 36-inch end bar. Then the 1 plus A plus B is equal to L plus D1, or 1 plus C plus D is equal to L plus D2. So on taking the average, 1 plus point half of A plus B plus C plus D is equal to L plus summation of D by 2. Let me consider this as equation 2. Now on comparing the same equation 1 and 2, we can call it as capital L is equal to 36 plus sigma by sigma small d by 4 minus sigma capital D by 4. So from the equation 3, the length of the end bar can be obtained. Thus the 36-inch end bar has been calibrated, and by this way unknown errors in the 36.5-inch end bar and the 1/2 inch blocks are systematically So this is how we can see in as I mentioned in the last figure how it is being arranged for the D1 and D2. So for the first L, the which is equal to 36 inch length standard bar is being compared with 35.5 inch plus A one side. So it will become that 35.5 inch plus A is equal plus D1 will be equal to 36 inch end bar plus this B. So similarly, when I am replacing this half inch block which is having, which I mentioned it as C and D, then I can arrange it, I can calculate the D2. This is the method of transferring the line standard to the end standard. Okay, so this is all about compare one is the line standard and another one is the end standard, and the wavelength standard we are discussed, and calculate comparing the or converting the line standard to the end standard we are all that also being discussed. I have used many internet sources and the textbook sources for the preparing this video. I thank to all, I acknowledge to all such sources, and thanks you for patient listening of this video. Thank you one and all.